All right, to start chapter 6, we're going to be working with polygons. The first thing to know is our interior angle sum theorem. It says if n is the number of sides of a polygon and s is the sum of the interior angles, then we can say that s equals 180. So rewrite that. S equals 180 times n minus 2. So n is the number of sides, s is the sum of the interior angles. So let's try that out with a few of the polygons that we know. Let's first go ahead and fill in all the sides of these because you will have to recognize these polygons by name. So a triangle we know has 3 sides. Quadrilateral, quad means 4. Penta means 5 for a pentagon. Hexagon is 6 sides. Hepta is 7. Octagon is 8. Nonagon is 9. Decagon is 10. With an 11agon, you can see it as how it's written right here, or it will be called a hendecagon, and that is 11 sides, and then dodecagon is 12. All right? So now that we know all the sides, that's our n. We can just plug it in to our formula. So 180 times 3 minus 2. All right? So 3 minus 2 is 1. 180 times 1 is just 180 degrees. And we know that a triangle adds up to 180 degrees. So let's go ahead and fill out all the rest of these. So with a quadrilateral, 180 times 4 minus 2. So really we're just doing 180 times 2, which is 360 degrees. All right? So then if we were plugging these in, doing them in the calculator, for a pentagon, we end up getting 540 degrees. For a hexagon, we get 720 degrees. For a heptagon, we will get 900 degrees. For an octagon, we will get 1,080 degrees. Now, you plug it in just the same as we've been doing, by the way, right here. I'm just not writing it out each time, okay? And then a nonagon is 1,260 degrees. All right, for a decagon, we have 1,440 degrees. For a hendecagon, we have 1,620 degrees. And then for a dodecagon, we have 1,800 degrees. And I got all of those from using this formula right up here, all right? So you can use this for reference, but what you'll be memorizing is this formula right here, okay? So that you can find it no matter what the sum of the angles are. All right? So those are the sum of the interior, and then we also will be dealing with exterior angles of polygons. So an exterior angle is the angle that is adjacent to the interior angle at that vertex. Another word for these two angles right here, so in this particular case x and 108, would be a linear pair. Okay? So if that helps you remember it better, because how we're going to solve this, if they are sitting together on a straight line, we know they add up to 180 degrees. So in this particular example, I could solve for x because I know that 108 plus x needs to equal 180 degrees. All right? So then we get that x is 72 degrees. So the exterior angle right there next to 108 would be 72 degrees. All right, so then your polygon exterior angle sum theorem. So now we're talking about the sum of the exterior angles is always 360 degrees. All right, so if they add up to 360 degrees, we can number all these exterior angles out here. So we could have the first one, second, third, fourth, and fifth exterior angles. There are 5 sides, so there are 5 interior angles, 5 exterior angles. So that's why they have added up all 5 angles out there that I have numbered, and exteriors always add up to 360 degrees. No matter how many sides, always 360 degrees. So then a regular polygon, we have to define that term. A regular polygon has equal angles and equal sides, okay? So, and that's important because If we are finding like an interior angle or how many sides of our regular polygon, then we can use this. All right, so if you see this word regular polygon, that's when you can use what we're about to do. So we're going to find the number of sides of a regular polygon. And what you are normally always only given is maybe this piece of information right here, that the interior angle is 60 degrees. Well, step 1 says if the interior angle is 60, then the exterior angle, I know they have to be a linear pair, so 180 minus 60 is 120 degrees. All right? So since all of the exterior angles, no matter what the shape, see it doesn't matter how many sides because we don't know how many sides yet, since they all have to add up to 360 degrees, you can use that knowledge to find out how many sides that must make up the polygon. So you take that 360 total degrees and divide it by the exterior angle, and it will give you the number of sides. So down here, we take 360 total degrees, and we'll divide it by one exterior angle, which is 120. So 360 divided by 120 ends up being 3 sides. So then I know this shape is a triangle. All right? So now we'll go ahead onto the back and just do some examples. We won't do all of them, but we will do a few of them just to make sure that we know what we're looking for. So A says, find the sum of the interior angles. So sum of interior angles is using 180 times n minus 2, which you do have to memorize. Okay? So a pentagon, you probably won't have that chart on the front to reference, so you will have to just use your formula. So 180 times 5 minus 2. You can type that all into your calculator exactly how I just wrote it, or I know that 5 minus 2 is 3, so really I'm just doing 180 times 3, which is 540 degrees. Okay? I could do a dodecagon as well and do 180 times 12 minus 2. So really I'm doing 180 times 10, which is 1800 degrees in a dodecagon. All right? So we're going to skip down to section B then. Given the measure of an interior angle of a regular polygon, find the number of sides. So we are given an interior angle. Remember, step 1 is find an exterior. So step 1, we're going to find that exterior angle. So 180 minus 140 is 40 degrees. And then step 2 is to take the total number of the sum of exterior angles, divided by one exterior, and we'll get our number of sides. So 360 divided by 40 is 9. So we have a 9-sided shape, okay, which is a nonagon. But we are just looking for the number of sides, so we can just write 9 sides. So let's do that again. Now I know an interior angle is 90 degrees. So exterior is 180 minus 90. So exterior angles are also 90. So step 2, sum of the exteriors divided by exterior, and you get 4. So then I know this is a quadrilateral that has 4 sides. All right? Let's go on to section C. Find the measure of each interior angle given the information below. Okay? Now, this is not a regular polygon. These are all going to be different angles, different sides, okay? But in order to add up all these, I'm going to do it similarly to what we've done with triangles, but I need to find out what the sum of all of these will be. So 180 times, I know this has 1, 2, 3, 4 sides. So I know this figure should have 360 total degrees on the interior. So then I just do x plus 4x plus 2x plus 5x equals 360 degrees, okay? Now this totals, if we combine like terms, we have 12 total x's equal to 360 degrees, all right? And then we get that x is 30 when we divide by 12. So then it asks for the measure of each interior angle, so we have to plug it back in. So this one right here, oops, there we go, ends up just being 30. 4 times 3 is 12, add a 0, 120 degrees. 2 times 30 is 60. 5 times 30 is 150. Now if you check 150 plus 60 is 210. 210 plus 120 is 330. 330 plus 30 is 360. It all is going to add up to 360 degrees. Okay? You can do the same thing for number 2. We'll actually go ahead and just leave that one for class. So let's go ahead and look at section D last. It says find the measure of the interior and exterior angles for the following regular polygons. Okay? So first things first, what we'll have to do here, we want to put some steps over here. Step 1 is going to be sum of interiors. We have to know what the sum of the interiors is. So a decagon, if you want to look at the front or use your formula, had a total of 1,440 degrees total in it. Okay? So our second step, that's the sum of the interiors. And if there are 10 sides, there are 10 angles. So to get my interior, I'm just going to do 1,440 divided by 10. So then each interior angle is 144 degrees. All right, so step 2, interior equals sum divided by number of sides. Okay, so then step 3, there's actually 2 ways we can find an exterior angle. We know exterior is equal to 180 minus our interior. So 180 minus 144 is 36 degrees. Now you could have done it differently as well. One exterior is also the sum of the exteriors divided by the number of sides, okay? And we could have looked, 360 divided by 10 is also 36. So whichever qualities of this stuff you might remember is what you would use to solve. All right, we'll do one more example of this. A nonagon has a total of 1,260 degrees on the inside. So to find an interior, 1,260 divided by 9 sides, so there's 9 angles, okay, is a total of 140 degrees for each interior angle. Then I'm probably just going to subtract from 180 here. 180 minus 140 is 40 degrees for an exterior angle. But if you did 360 divided by 9, you would also get 40. All right? And we will do the rest of these when we get back in class. Make sure this is all filled out, and we'll see you next time.